So in the first 5 terms of the recursive sequence, so remember what recursive means. Recursive means you need the previous term in order to get the next term. So I like to list it like this. I don't need you to list it like this, but if you choose to do that, which is great, make sure you're showing your work. If you choose not to do that, make sure you're showing your work. Don't just give me the first 5 terms. So I know the first term already. That's 4. And then now I need to take that previous term, and that's going to go in there. So now I'm going to go 4 plus 15, 19. Now I'm going to take this previous term, it goes in for there. And now I'm going to keep playing the same game, take this previous term to get the next term. So really all I'm doing is adding 15, which I think some of you will see that. So if you want to at that point, if you show me work here and you just go plus 15, you can go like that and you can go like that. I'm fine with that, okay? Just make sure you're showing me that you know that that pattern's plus 15. If you didn't know that, you'll go like this and then you'll go like this and that's fine. Show me a little bit until you've established the pattern. Show me the pattern, I'm a happy girl. So 4, 19, 34, 49, 64. Make sure you list all 5 terms. Some of you forgot to list the first term. Okay. Next one, find the first 5 terms of the explicit sequence. If it's a fraction, there needs to be a fraction in the answer. Okay. So 1, 2, 3, 4, 5. Okay. I should have made, it's not really very much space. You know what? I'm just going to use scratch paper here. I'll redo it. 1, 2, 3, 4. Okay, so I'm taking negative 1/3 and I'm plugging in 1 minus 1, negative 1/3, 2 minus 1, negative 1/3, 3 minus 1. I'm hoping that the most annoying thing about this problem is actually just writing negative 1/3 so many times. Okay, 1 minus 1 is 0. Anything to the 0 power is 1. 2 minus 1 is 1. Negative 1/3 to the first power is negative 1/3. 3 minus 1 is 2, negative 1/3. If you square 1, it's 1. If you square 3, it's 9. 4 minus 1 is 3. If you cube 9, it's 1. If you cube 3, it's 27, negative. 5 minus 1 is 4. 1 cubed is 1. 3 to the 4th, 1 to the 4th is 1. 3 to the 4th is 81. I don't know if any of you noticed, but this is the pattern, okay? So now that I have that, I will list it. 1, negative 1/3, 1/9, negative 1 over 27, 1 over 81. Part of what makes this the pattern, positive, negative, positive, negative, positive. So be careful. Okay. Please don't get those 2 wrong. All right, write the series, write an explicit rule. So if it's saying write a rule, that means I want something like a sub n. Okay. So first thing I have to do is I have to determine if it's arithmetic, plus, 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 or geometric, multiply, multiply, multiply. So I see that it's getting smaller, it's not subtraction. I notice that it's divide by 2, but I can't write it as divide by 2, so that's 1/2. That means I know it's geometric. That means it is this rule, okay? So now what I've got to do is just take and plug it in. So I plug the 8 in there. I plug in the pattern, n minus 1. All I want is the rule for that question. That's it. So remember, first you have to determine what type of pattern it is, then decide which formula to use, then plug in the necessary information. Okay? All right. This time I want it in summation notation. If I say I want summation notation, I want this. You can use an n, a k, whatever you want to use. But since we've been using n a lot, I feel like n is the easiest. You don't have to start with the first term. You can start with the second term, okay? But if you're saying this is the first term, 1, 2, 3, 4, 5, 6, that would be 1, 6. If you say that's the second term, then that's the 7th term. So just make sure it corresponds accordingly. I think n equals 1 is the easiest. If you say this is the 0 term, then this would be the 5th term. So just make a decision on how you're going to do it. I then have to decide, just like this one, if it's arithmetic or geometric. I notice that the pattern is plus 8, which means it's arithmetic. Always going to write down the formula. The more I write it down, the more I memorize it. Now I'm going to plug in the necessary information and simplify. Because remember, arithmetic is more difficult than geometric. Geometric right here is already simplified. And then the pattern is 8, distribute. 8 minus 8 is gone. So a sub n equals 8n. So I just write 8n right here. And that's it. Now, how do you know you're right? Well, I can check it. 1, 2, 3, 4, 5, 6. I think this is the 6th term. So if I plug in 6th here, 8 times 6 does equal 48. So I'm good to go. Okay. All right. This one is in summation notation, and I gave you a complex function. So I'm going to do exactly what I did up here, which is 1, 2, 3, 4, 5. So now what I'm going to do is for the first, I'm going to take these, and they're going to go in for k. So again, I'm going to make more space here because I think we need it. So I'm going to take that, let me move this up a little bit. I'm going to take the 1, and I'm going to go 1 plus 2 over 1 plus 1. I'm going to take the 2. 2 plus 2 over 2 plus 1. 3 plus 2 over 3 plus 1. 4 plus 2 over 4 plus 1. 5 plus 2 over 5 plus 1. Okay? It's a fraction. Give me a fraction as the answer. 3 halves, and that's simplified. 4 thirds, simplified. 5 fourths. I'm noticing a pattern. 3, 4, 5, 6. 2, 3, 4, 5, 7, 6. Okay? But I don't just want you to list them, so I want you to see the difference. In the beginning problems here, I want you to actually tell me the terms. But when you see this symbol, it means what I want you to do here is now add them all. So this is when I would get your calculator out. I'm going to grab one real quick. So you can use the simple calculator, but I feel like it's easier to use the complex. So every time I have a fraction, control divide, 3 over 2. Make sure you get out of there. Let me zoom that in a little bit so you can see it. So I press the right key. Now plus, control divide, 4 over 3. Go to the right to get out of it, plus control divide. Oops. Now you want to make sure you don't get this wrong by plugging in the wrong thing. So just double check, because that's annoying for you. 7 over 6. Oh, and that's it. And then I press enter, and it gives me 129 over 20. So now that I have that, I'm going to write that the sum of the first 5 numbers is 129 over 20. Because it goes from 1 to 5, you can tell me that. I want to point out that if it said this, and it was k equals to 16, you cannot write the sum of the first 16 numbers because it starts with the second term. And you can't even do the 15 because it's not the sum of the first 15 numbers, so that's confusing. So you would just give me an answer without that. But because it starts with 1, you can give me that as an answer. All right. Now, these two are very similar. They're similar because they're all in summation notation. But these ones have formulas. And this is the formula that you learned on the previous page. So you just have to memorize this one, and this one. This is when there's just a number. This is when it's a linear, and this is when it's just quadratic. Now I want to point out that you want to be clear which one's which. This is linear, k to the first. This is quadratic, and this is just a number, okay? So because I know, and it's going to be just like this on the test. So you're going to identify which one is which. So linear, n times n plus 1 over 2. There's 2 n's, okay? And then this one is just this times how many numbers there are, which is 30. Oh, but it started with 10. So there aren't actually 30 of them. There's 21. And because the formula is this minus this plus 1. If you don't believe me, you're going to go 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and you'll see that's 21. So you can count to 21 and make sure that you're good to go. Now, what I like about this one is it's kind of like this one. So it starts the same, n plus 1. But this time, because it's squared, it's got the 2n plus 1. And over 6, Here's how I remember it. 1, 2, 3, 4, 5, 6. I memorize that. So now that I have all the formulas down, now I'm just going to plug it in. So I'm going to take that 25 because it starts with the first term, and I'm going to plug it in. I'm going to take the 10, and I'm going to plug it in. And I'm going to go 30 minus 10, which is 20 plus 1 is 21, and I'm going to plug it in. So I'm going to go 25, 25 plus 1 over 2, 10, 10 plus 1, 2 times 10 plus 1 over 6. Okay, so options are you can go straight to the fancy calculator and plug it right in. I'm too lazy to plug it all in, so I'm going to go 25 plus 1 is 26. 2 divided by 26 is 13, so I'll go 25 times 13, and I get 325. Now, since it starts with 1, I can say the sum of the first 25 numbers is 325. If you just give me 325, you're wrong. Now, if this problem starts with a 2, you would not give me that because it's not the sum of the first. All right? So this is 11. 2 times 10 is 20, plus 1 is 21. I don't want to plug in everything. I could actually do this. 21 times 11 is 231, times 10 is 2310 divided by 6, which you're probably thinking, why would she do all that when she can just plug in her calculator? I don't want to. The sum of the first 10 numbers is 385. Okay, let's try the next one. I'm just going 4 times 21, which is 84. But I cannot say the sum of the first 21 numbers because it starts with a 10. Okay, all right. Let's go to the next one. Determine whether it could be arithmetic. If it is arithmetic, minus 11. Determine the difference. Some of you got this wrong because you didn't write D equals negative 11. You have to tell me that you know it's a difference. And then tell me the next term. So it's arithmetic, yes. D, and then the next term would be 22. Okay? So you're going to write, not 22, you're going to write A sub 1, 2, 3, 4, 5 equals 22. Okay? Make sure you do that. You'll lose a point. Find the 9th term of the arithmetic sequence. I am not okay with you continuing to go and cheat and get the answer in your calculator because that's something you can do. What I need you to use is the formula. A sub n equals A sub 1, n minus 1 times d. So you're going to go 1/7 plus, okay, I want the 9th term, and the pattern is plus 2/7. Do you think I want you to show me that you're not using a calculator? Yes. So 9 minus 1 is 8. 8 times 2 is 16. So I have 1/7 plus 16/7, which is 17/7. You need to show me that you're not using a calculator. A sub 9 equals 17 over 7. And I want to be clear. When do you use S? When do you use A? You use S when I'm asking you to find the sum. You use A when I want a certain term in the sequence or I want a formula. Okay? Missing terms. You could obviously do guess and check, but you need to show me 2, 3, 4, 5 that you did not do guess and check, but you can guess and check to make sure you're good to go. All right? So what I'm going to do is I'm going to go A sub n equals A1, n minus 1 times d. My first term is 26. I'm going to use my 5th term to find the pattern. Remember, who has the power? The pattern. So I'm going to go plus 5 minus 1 times my pattern. I don't know it. If I knew my pattern, life would be easier. So I'm taking my 5th term. Subtract 26. I get 52 equals 4d divided by 4. My pattern is 13. Now that I know my pattern, plus 13, plus 13, plus 13. Don't give me the answer of 26 and 78. Those are not my missing terms. Those are the terms I see. 26 plus 13, 39, comma. 39 plus 13, 42, comma. Plus 13, 55, comma. Plus 13, 78. I know how to add. Good to go. I do not need you to write A sub 2, A sub 3, A sub 4. I'll do this problem in the second video.